Welcome to the Cannabis Data Science meetup group for the 1st of September. I hope everybody's doing well. Crunching numbers here in Oklahoma again. So I've prepared some data that I can share with you, essentially trying to look at the market competitiveness on a county by county basis here as we do our national analysis. Thought I would drill down here real quick since we have county level data. But before we dive into that, I guess, welcome to the group, Katie. You and of course Heather's here. And then Katie, you wouldn't mind introducing yourself if you want. You don't have to, but just curious what avenue you're coming at the group from. Oh, it's okay. Always happy to have people listen. So without further ado, I'll share with you some of the work that I've been working on, and we can maybe even spearhead and do some new development. Okay. So we've started, as you can see, we've got a blank map here. So we're just now starting to essentially try to populate data, all the public cannabis data that we can scrounge up for each state. So of course, many states here in the Eastern Seaboard, as well as some here in the South, don't permit cannabis. Some of them neither medicinally nor recreationally. And then many states don't allow cannabis recreationally. So we're going to be collecting all the data that the states provide on either and/or recreational and/or medicinal cannabis. So for example, Washington State, Oregon, you still have medicinal programs as well as recreational programs. So we'll try to track that data. Same for Colorado. And then states like Oklahoma just have medicinal sales. And then, we've got Illinois, Michigan, and then we'll take a look at Maryland, and we'll look at some of the northeastern states as well. So Maine has some good public data. We'll see if Massachusetts has any data. And then, some of the southern states do have medicinal markets. So Florida has medicinal cannabis sales. So we'll see if there's any data there. And then, of course, we can't forget Alaska and Hawaii. I think Hawaii has medicinal, and then Alaska they have permitted cannabis. I forget if it's recreational and or medicinal. And then we may even look at a few other territories, essentially. So Puerto Rico has some sort of permitted cannabis, I believe. And then I was looking, and Guam has cannabis. So they may be worth looking at as well. So for now, we were going to drill down on Oklahoma. And so, pardon that this map is small. I'll be working to render this larger in the future. And so, well, that's Texas County, Oklahoma. And so essentially, we'll want to look at a county by county level analysis. And so one measure of market competitiveness that was brought up at the cannabis conference was, okay, let's just look at the total number of licensees per capita. So that could give you an idea if there are any markets that may be underserved. So if there's a high number of licensees per county, then that county may be getting saturated. Whereas if there's a low number of licensees per county, then that county may be ripe for it for trying to set up a new license, or there may be a reason for that. There may be, or it may be hard to do licensing in that county. So there could be a variety of factors. So what tools, what tools and data do we need? Well, first, started to just go ahead and write. So first, just posed our question. So okay, we're looking at licensees per capita in Oklahoma. We would like to look at licensees per capita by county. Of course, our null hypothesis is there's an even distribution of licensees per state. No one county has a statistically significant difference than another. And we will reject this if we can conclude that any counties do have a statistically significant number of licensees than another. So that's a research question. So let's get to work. So first things first, we need the number of licensees in Oklahoma. I have, for Canlytics, put together a script that collects data, public cannabis data for Oklahoma. And so this is MIT licensed, so anybody can use it for any purpose they wish. Just make sure to give a link back to Canlytics as the copyright holder. However, this script essentially just collects data from various sources. So we're not looking at revenue at the moment. We're just looking at licensees. So essentially, Oklahoma provides a running list here of licensees. So essentially what the script does is, okay, it just downloads all of these PDFs, parses this data into a usable format. So there's the raw data. And then you can use this script here, and you can get a decent list of licensees in Oklahoma. So now we know, okay, we've got you've got the licensee, their trade name. So a lot of companies may, not a lot, but a handful of companies may do business under a different name than their registered business, their licensed business name. So for example, here we've got a license that's licensed under Donald P. Northcutt. However, they're going to be packaging as Big Bud. So you're going to know them at the store as Big Bud. So this is not uncommon. in the cannabis industry. Here's Oklahoma. So just to just not to say what anyone's doing per se, but a lot of times you may see it essentially to help with banking. So it's still tough for cannabis businesses to get banked. So these people, could be doing things for different reasons. However, it would probably be easier to get banked under agency properties versus Oklahoma. And that's just the tragic nature of the state of affairs. And so okay, but so long story short, we have many companies here in Oklahoma. So some including every licensee that's plant touching in some way, from waste disposal to laboratories to dispensaries to the growers themselves, and of course processors and the whole shebang. There's almost 13,000 plant touching businesses in Oklahoma. So where are they? Are they all right outside of Oklahoma City? Are they all out in the country? So we know what city they're in. However, we'll actually, we could even look at the zip code. So I didn't even realize that we could get that granular. So for this analysis, we'll just be looking at the county. So we'll try to get a county by county count. So without further ado, let's try to do just that. So let's just run a quick Python script here. Okay, so essentially we're just reading in the licensee's data. And so this is the data we just saw in Excel. So we can just do some sanity checks here. For example, let's look at, okay, what are all of the license types that we did in fact get? So, like we expected, we've got the growers, the labs, the waste disposals and dispensaries, and we also have processors and transporters. So, you could find out how many of each there are. So if you wanted to do that, which, I mean, why not? So I'm a little curious, okay, how many of each are there and what's the percent of the total? Because, well, we can do a little exploratory data analysis since this is the first, real good time that I've had to look at the licensee's data here. So let's look at it together. So the way I would do this is, okay, so let's look at each of these types. So for the license type, okay, so what do we want to do here? So we want to isolate data for that type. So we would just locate the licensees, where the licensees license type is equal to the license type. Okay, not so bad. And then what do we want to do? Well, let's just print out some statistics here. So a statistic is a total. So we could just say, okay, what's the total number of license type? That's just going to be the total number that we just found. And then I'm also curious, okay, what's that as a percentage of the total? So let's just say, okay, so what's that as a percent of the total? Well, that's just going to be, the length divided by, all licensees. Then I'm just going to add an extra space here, just so things print out decently. And then let's also maybe just format this decently. So let's round this times 100 to 2 decimal places. Okay, so now the numbers look a little cleaner here. Okay, so this is interesting. We can start to, these would be good numbers for a pie chart here. So that way you could actually see, okay, what are the pieces of the pie? For now, we'll just look at just the raw numbers. So, okay, so this is actually surprising. So I knew it was going to be a high percentage. For some reason, I was thinking higher. Just my what do you call it? My naive prior would have been higher. However, it's about 70% of all licensees are growers. About 12% are processors. That's interesting. I would have thought higher, but about 12%. That sounds about right. I would have thought about 20%, but that sounds about right. Well, yeah, so maybe that's more growers than I was expecting. So you have, yeah, about 12% processors. Well, should we try to do a quick pie chart just for the heck of it, since we're crunching numbers here and that's what we do? So let's do a matplotlib pie chart and see if it's not the hardest thing in the world. Because if we can get a pie chart, thrown together, in a couple minutes, then also I'm going to spin this down. Yeah, I think we could look at some of this data here. So let's look at a quick pie chart here. So, right, because we're already looping through this, so all we have to do here is just collect these points that we're what we're trying to do, right? So we just have to collect what they're calling the sizes here. So the size of each piece of the pie, right? So all we have to do is keep track of the proportion that each license type makes up. And look, we're already calculating the proportion, so that's easy enough. Don't really need to explode anything. In fact, we're trying to do the exact opposite. And then it looks like they have their labels as a tuple, but we're going to try to do our labels as a list and see if that works. And no one caught me. We need to append these, not. Okay. Okay. And we don't really need to do anything fancy here. Okay, so let's see if we can't make a quick pie chart just to get a bit better of a visualization here. Okay, and look at that. So now we can actually look at the data. So let's just keep track of this code just in case we need it for the future. Okay, so we've got the growers making up about 68%, processors 12%, dispensaries about 18%. So that's quite interesting. So about 30% here, processors, dispensaries. And then look, just this tiny little sliver. So you have about 1% of all the other companies as transporters, laboratories, waste disposals. So you have a very small number of these almost ancillary plant touching businesses, so that still make the industry function at the end of the day, right? So you need transporters to get products from point A to point B. In certain states like Oklahoma, you really need to pay attention to waste disposal. So there's waste disposal companies, and you need your quality control. So you've got the laboratories often doing the state mandated quality control tests. So that's the breakdown of licensees. Let's go ahead and move on. Not trying to get too bogged down in that. So we've got our number of licensees. Okay. And let's not lose sight of what we're after here. We're after the county by county breakdown. Okay. Let's get a couple data points before we continue. So, because we were trying to get the population. So, a quick aside. The place you want to go if you want to get reliable, credible, economic data points for economic indicators such as population, the place you want to go is the Federal Reserve Fed. So this is an economic data repository. It's public, open to the, it's free, and you can use it via API, which is what we'll do here momentarily. And this is a trusted data source, so no one will be too hard on you if you use the Fed data. Of course, they may say, "Oh, why did you use the not seasonally adjusted series or this or that?" However, they won't try to undermine the data source itself. So that's why it's credible and reliable. So that in that regard, I would still hedge the data in that, okay, the data is still probably, not probably, it is an estimate of the population here. So, it's probably not spot on to a T, However, we can get a decent measure of the population here. And so, for example, here we just have, okay, here's just the total population in Oklahoma times 1,000. So this is thousands of people. So just shy of 4 million people in Oklahoma. And then you can get this on a county by county level basis. And so, for example, this is LaFleur County has almost 50,000 people. So long story short, we can go ahead and get those data points just using the Federal Reserve API. So we can get the population of Oklahoma, and then we can actually get the licensees per capita. So this number on itself may not be that informative/interesting. However, what would be interesting would be to calculate this number, licensees per capita, for all of the states. So that way we can see, okay, which states, how do the different states shake out? So for example, Illinois, I think there's only, a handful of dozen, so, a couple dozen to maybe more licensees in the whole state. And so if you think about the population of Illinois, then this number, licensees per capita, is going to be much smaller than it will be in Oklahoma. And so the scale will be interesting. So the scale there will be interesting. So we can't do state to state yet. So let's look at county to county. And so basically what I've done here is I've just gone ahead and gotten the Federal Reserve FedFred code here for looking up each county. And so this will be the first time I've done this. So long story short, let's try to look at the licensees per capita in each county. And ambitiously, we may try to plot this. It could be a wild one, but we're going to try. Okay, so without further ado, let's start looping over these counties. So we'll just kind of do this on the fly, right? So, okay, so we want to do it for each county. We know that. So for county and counties, well, what do we want to do? We want to find all the licensees in that county. Then we want to get the population of that county. And then at that point, we just want to calculate the licensees per capita in that county. And we want to keep track of this. So I'm just going to create a dictionary here, because we've got a dictionary of states, and because just heads up that I kind of know this is how I want the data presented here in a second. So that's why I'm formatting it like this. So we then do licensees per capita. Okay, so first things first, we want all the licensees in that county. So the county licensees, oh, well, that'll be simple enough. That's just going to be the licensees where the licensee's county, correct, is equal to that county. Simple enough. And we want to get the population of that county. Well, we know how to get the Fed-Fred data. So we've got the county population. And then we got the county code here. Oh, that's right. And I want to make sure this is equal to the county name. Okay, because we've also got our county, I just called it pop ref. So long story short, we want to get this. Okay. And then we would just want to calculate the licensees per capita in that county, which we did for the state. So we can use that same logic once again. So this is just going to be county licensees per capita. And that's just going to be the county licensees divided by the county population times 1,000, since these are in thousands of people. Cool. So we now should have that. And then basically we want to keep track of the data. And the way I'm doing it is in the dictionary of county. And then I actually want some variables here. And then basically I want to keep track of this as licensees per capita. So that's how I'll keep track of this data. So that should work. Let's just go ahead and, print some, print some data out here, just so we can kind of see what we're doing as we're going. So we're just going to say, okay, what's the county? What's the population of the county? And what's the number of licensees? And then finally, what is the number of licensees per capita? So just go ahead and print that out for each county. And I'm going to go ahead and just print a separating line here. And let's see what happens. We got an error, and that's because I was not using this county name here. So let's just go ahead and define a new variable in the Pythonic way. County name. So simple enough. And we are cranking out some calculations here. Awesome. So we just printed out, probably printed too many lines here. We just I probably should just print count. Once again, print, oh well, print county name. Okay, so long story short, we've got our counties here. We've got the population as of 2020. So keep in mind, this is the 2020 population. So all of these numbers are done with 2020 population. So we now have the number of licensees. And then we also, so for example, you can really start to compare these counties, right? And so this is where you may start to get a measure of competitiveness, right? Because, okay, Adair County has already issued 118 licenses. Atoka County has issued 76 licenses. However, Atoka may be slightly more saturated with licensees than Adair. Just slightly. And so this is where, okay, you may not necessarily just want to look at the total number of licensees issued per county, but you may actually want to measure them based on licensees per capita. So we now have this data, and so now we want to look at this data. So there's two ways we can do this, the easy and the hard way. So the easy way is just, if this just works with my JavaScript, map here. If not, we'll have to make a map in Python. What am I trying? Oh, yes. So right now I just need to print. Right now I just need to print the licensees per capita. And then let's see if this data just works nicely with this Oklahoma county map that I've been tinkering with. So hopefully that's going to be a bit of a problem. Okay, not the end of the world here. So real quick, I just need to format this name real quick. So basically this just needs to be okay underscore county name, where the spaces are replaced with underscores. So sort of a pain here, and I'm sorry, Fred, that I'm about to make a bunch, 50 more API calls, but that's what we're going to do. Okay. So we're getting this data nice and formatted here. But for some reason, I don't think we'll have a chloropleth right out of the box. Unless we're somehow able to yeah. Okay. So I'll try to do this. Oh, we'll try. This could be interesting. So long story short, we're going to try to visualize this data, which is tricky, right? Because it's state data, it's geographical data, but we're going to try here. So long story short, we are trying to color this map. So we're trying to color this with places with more licensees to be darker than the places with less licensees. So I'm going to show you a little bit of web programming here. So we just dump in our data just for the time being. Normally you would get your data from the server, right? So normally you get that from your database. Okay, so we've got our data here. What we can do is we can actually add a little tooltip. So bear with me. Okay. Bear with me. So, okay, so first things first, let's just see if we can't just plot all this data here on the map. Okay, cool. So now we can at least see the numbers. However, we want to get them colored. Also, I wonder if we can't do something like, I forget what it is off the top of my head, but I don't think it was that. Well, this is what Google's for. Oh, it's to fixed. Okay. So to fixed. All right, and let's give it a few more decimal places here. Awesome. So now we have licensees per capita by county in Oklahoma. And so we've got 15 minutes left. Let's see if we can't color these. So sometimes there's a proper way and an improper way to do things. So the proper way would be if somehow we could, I wonder if this variable is going to be accessible right here. Doesn't look like it. Interesting. Okay, so we may have to resort. Yeah. Hold on. This may just work. Um, Okay. So the problem is this is probably like much smaller of a number than necessary to give us a good range. Okay, so this may end up waiting for the future, or we can maybe try a Python chloropleth real quick. Just trying to scale this a bit. Okay, the last shot here. Hmm. Okay, so we may not be able to get this JavaScript working right this second. So let's see if we can't. I'm not confident that I can get a chloropleth going here in in 10 minutes in Python. Um, well, okay, here's the deal. We'll try it. We'll give it 10 minutes and see if we can't make a chloropleth of this data in Oklahoma in Python. And then if not, I'll finish this later. I'll finish this plot later today and then post that link. So this is how you make a chloropleth in Python. So it's going to be tricky. Well, it may not actually be as hard as one may think. So let's see if we can use this handy dandy Oka package and do this work for us, right? Because we're not trying to reinvent the wheel here. Okay, so let's see what this yields us. Okay, do we just have our county names here? Okay, those look like the Oklahoma counties. So that's cool. We already have the licensees.
Check out these pictures.
We already have the licensees. And so what was this Boca chloropleth doing? So let's just grab all of this. And so we've got our county names, and we're just trying to make this chloropleth. Okay, so it says, okay, so now we define the county shapes. And let's hope these are defined already through Boca. It looks like they are. That's awesome. Looks like we need a couple of Boca's plotting tools. That's okay with us. Okay, so the main thing we need are our values. So that actually shouldn't be the hardest thing to do. Maybe just partition our values. So, let's just do it in the order that county names is in. Right, so we basically want to define our values here. Okay, and so we'll want to just account for maybe just in case any of these counties don't have any. So what we want to get licensees per county. Get, so we want to get the value for that county name. If we don't find anything, then we don't want it. And this is just because this is how how I formatted this data above. Okay, actually, I'm going to need to just do something here. Okay, so this just didn't work. I may revisit this later. Trying to do this on the quick. I think I can finish. Okay, so we've got our licensees per capita. And then let's just do this simple, right? That's sort of the analytics model. And we're going to have to clean up all this code later. Okay, so we've got a much more simple dictionary now, with just the county name, value. So that should make making these values much easier to get. Right, so now our value is just going to be licensees per capita again. Okay, much simpler. So let's get all our values. And this just may work. Oklahoma. Right, so this is the Oklahoma cannabis licensees per capita. Well, let's see what happens. We've got 5 minutes left to debug. If anything goes askew. And if not, I'll get the JavaScript up and running today. So thanks for bearing with. Thanks for bearing with as we went through this exploration here. But you saw us firsthand how we go about scrounging the licensees' data, supplementing it with population data from the Federal Reserve, calculating licensees per capita, and ideally providing a visualization here. And we've got an obscure error that I'm not certain I can debug right here on the fly. One can hope it's just some problem with these tooltips or something. but okay. So we unfortunately not certain what these values must have looked like. I don't think it's the values, so there must be something. Plot width. So what is going? So let's just try to just remove these. Maybe. Oh. We've got a success, but nothing showed. Probably because we don't have a plot size here. Okay. Oh, that's so bizarre. So it looks like we're so close, but yet so far. Um, so we may have to, I'll give it one shot here in Spider, just, just to see if there's something just going on with the plotting, but otherwise I may have to send it to the final output to you afterwards. Just a little bit of a letdown because I was real curious to see this data and talk about it here. So let's just do one quick Google search and then we may have to just oh, that's right. So it gives us this HTML. Hold on. We may just have a plot here. That's bizarre. We may just have a plot. That would be bizarre if, well, by golly, something happened. I don't think this is what we quite wanted, was it? So this appears to be Oklahoma with only some of the counties shaded in. And so long story short, going to need to touch this up a bit. But what you can see right off the bat here, so there's going to be a lot of cleanup that needs to be done. So thank you for bearing with this initial foray. But this is, I mean, this is interesting right off the bat. So it's going to need to be cleaned up a bit. But as you can see, the counties that even permit, it looks like cannabis licensees are limited. And so it looks like I want to get the actual numbers here and get this shaded in. But surprisingly, it looks like a wide swath of the licensees are in this eastern crescent here. So I apologize that these maps were finicky and not behaving well. And so that's the thing with geographical data. Like, it is a wrangling process to get these maps to work. And so I'm going to spend a bit of time today and get these cleaned up because this is a little embarrassing. And so for next week, I can point you to the Canlytics state data trove as we fill in state by state. And so, and hopefully county by county. So it's going to be a little bit of a journey here, getting all this data processed and presentable. However, we're on the right road. So I did my best to present this data. We'll give it another go again next week. So thanks for bearing with this ad hoc data presentation here. And I'm going to go ahead and wrap it up there. If there are any questions, I can field a couple of questions before concluding.
Hey, I actually had a question.
By all means.
So sorry about earlier. I was having trouble getting my microphone unblocked. But I'm pretty new to data science. I was just wondering why you decided to pick Python to examine your data.
Good question. That's sort of my tool of choice. So it's just what I'm most comfortable with. So I work with a couple people and they like to use R. So that's their first go-to choice. So for me, I find it simple. It just generally reads like English. I find it powerful. Basically, I find if I want to do something with Python and it can be done on a computer, I can do it, which is awesome because then, like you saw today, the Oklahoma licensees data is in a bunch of PDFs. And so I found, okay, well, that's on a computer. I would normally download those PDFs and put them into Excel by hand, manually. With Python, I can download all those PDFs, scrounge all the data, get it into Excel with the click of a button. I'm sure you can do this with other programming languages. So I'm sure you could potentially do this with R. You could definitely do this with C or who knows. I'm not that well versed with programming languages. That, you know, there could be Java or potentially PHP, what have you. So it's, to me, I see them as tools, you know, means to an end. So I just picked Python because I knew I could, well, I didn't quite get the job done, but I knew I could get, given more time, I could get the job done. So I knew I could get the job done with Python. So So that's why I chose it. So does that answer your question?
Yeah, for sure. Thank you.
How about yourself? Do you have any go-to tools that you use for data science?
So far, no. I'm going through the Thinkful program at the moment, and I finished with Excel, and then I'm pretty close to finishing SQL, but I haven't started with the other ones yet.
Okay, so the sequel will be, okay, that's where, okay, yes, we need to store our data in the database. I myself am not the biggest SQL expert. I a lot of the times use NoSQL Firebase. And so that's like the JSON, like dictionary formatted data. For me, it's a bit more natural, and that's what I gravitate towards. So my recommendation, of course, I'm biased, but my recommendation would be what you may want to try to install Python and try to do a little bit there. Try to figure out, okay, what are some of the repetitive tasks that you find yourself doing? Oh, I'm downloading this data set on every week, or oh, I keep searching for these journal articles or this or that, and just find things that you do repeatedly and automate them. And so you could set up what's called a cron job. So that's just have your Python script run automatically. So you could have your Python script run every Monday and get you data for the week. So that's my personal recommendation. Python's got a close place to my heart. So maybe it'll find a place near your heart too.
Yeah, hopefully. I think we're learning that next, so I'm excited.
Okay, well, my recommendation is make it your own. So, like a lot of times, you get out of things what you put into them, and so that's why I learned Python in a computational economics course, and it was one of those things where I just fell in love with it, and I realized, oh wow, I can make really cool plots with Python. And so I just went out of my way to, whenever I needed to make a good looking plot, I would do it with Python, no matter how hard or arduous it was. So, but it was worth it. It paid off because the cool thing is once you write the code, you have it. So although it wasn't that clean, right? I was digging up this old bokeh chloropleth chart that we had done months ago. And so with a bit more tinkering, we could get it to work. But long story short, you can, and that's the importance to writing clean code, is so you can just pick it back up months later and use it. That was not clean code, could not pick it back up and use it. That was unfortunate. So long story short, you can write these awesome tools for yourself, which will be there for perpetuity, and the sky's the limit. So that's my promo for Python.
Thank you.
Yes. On that note, future Pythonistas, I want to go ahead and wrap it up for today. Just don't want to just to stay, to spread it too long. But like I said, there's still more cleanup to be done here. So for next week, we can have some real beautiful looking charts. And so that's what I'll be tinkering on. But you can at least, I think it's important to see the process, because it's not like just someone waves a magic wand or, flashes their little curtain or what have you, and then so people don't just wave a wand and things are made. There's tinkering to be done, and there's mistakes to be made along the way. And so as you saw, we've got some ugly looking charts along the way. We're making some mistakes. We're figuring this out, but you'll see next week the sausage will hopefully we'll get some good visualizations out of it. So that's the idea. So, on that note, thank you both for attending, for coming today. Then definitely feel free to reach out if you have anything you want specifically covered in the coming weeks. And then next week, we'll be moving on to more states and just trying to fill in this map and get all the public cannabis data that we can and make it available. All right. I'm going to end the recording here and see you both next week.